Hi everyone. In this presentation, I'm gonna show how to train your own neural network and then convert it to ONNX and deploy it to your iPhone. So as an example, I'm gonna train a mushroom classifier, an image classifier with mushroom species from my region. And for this, let's start with an iconic mushroom, the fly agaric, Amanita muscaria, which it has its own emoji. And for this, we can use the species name Amanita muscaria, and then use interpreter and with the species to obtain the entity of the fly agaric, and then as for properties like the image and get this thumbnail image. In this case, we want hundreds of different images of all kinds of mushroom species. So for this, there is a new Wolfram function repository that I did a couple of months ago. It's the iNaturalist search function. You can explore a bit its documentation. It has some examples. Basically, it calls to the API from iNaturalist community. It's a community of citizen scientists that record all kinds of different species into the wild. So for this, we need to get the function using the resource function iNaturalist. You can get the function, and in the first argument, we will need to specify the mushroom species, and then we want to make sure that it contains, the observation contains an image, and also we want to make sure that they are research grade observations. That means that at least two other iNaturalist users have agreed that that's a certain species. And then we want to get, for this case, 50 images was bringing, was creating a classifier that was good enough. And I'm interested in species that are in my region. I live in the frontier between France and Spain in northern Catalonia. So I wanted to rule out some subspecies that were in the state, for example. So I could ask for observations that are only in Europe using observations geo-range. This will create a data set of 50 observations. And for example, this is the data for the first observation in the data set, having 28 properties, such as the scientific name, the Wolfram species entity. Then there is also, in certain cases, if applicable, there is the Wikidata external identifier, and things like the geoposition, observation date. And here what we are interested is in the images URLs. And also, just as an example, so for those who haven't tried iNaturalist, it's a nice platform. In this case, this Amanita muscaria was found in Denmark. Yeah, and with Wolfram language, it's super easy to get the image with import. And the idea was that I would build a image classifier with some toxic mushrooms, the most common ones in my area, and some edible mushrooms, 11 most common ones. So these are like some utility functions for getting the images, and then also doing some kind of cropping the center of the image and resizing them for later training of the neural network. Then I was storing the images with export using the scientific name and also the attack, whether the mushroom was edible or toxic, poisonous. We can test that this function works well with another Amanita, the death cap, which is deadly mushroom. And these are a few images that we got from iNaturalist. We can do the rest for the rest of the mushroom species. And then for generating the training set and testing set, I'm gonna create the class labels as a, kind of a list of strings, and create the examples as a list of key values. The keys are the image, and the values are gonna be the labels. And we have 850 images, examples of these 17 mushroom species. So finally, we only need to create a randomized training and test set, which can be done with a take drop, random sample. And the thumb rule is to take 10%, between 10 to 15%, and keep it for the testing set. So for doing the transfer learning, I'm going to use a pre-trained net model from the Wolfram Net repository. For those who don't know about it, there's a bunch of pre-trained neural networks which can be useful for your task. Here I'm going to focus on the Wolfram image identify net version 1, which was the one also, I think, originally used for the image identify built-in function. You can get the model simply using net model and the name of the model. And a good thing to do is also to check the size of the network, since we are aiming to deploy it into a smartphone. It should not be much bigger than 100 megabytes. In this case, it's 60 megabytes. So what we are interested is in this part here, from the convolutional first convolutional layer to the last pooling layer. So we will use the net take on the pre-trained net, and then using the net join, and we can add a linear layer with 17 classes and a softmax layer, and finally an output with a decoder with the classes that class labels that we created earlier. So, and as a last step, we just need to train it with net train, keeping the pre-trained weights fixed, and also adding a validation set for around 10% of the training set. And for me, it was yielding already good results, doing 15 training rounds. And the method is a stochastic gradient descent. And it was doing a fairly good job. It took around like 9 minutes on CPU, on my MacBook Pro. And so we can also now check the performance plotting the confusion matrix, either using the net measurements or the classifier measurements function. Here I was using the classifier measurements, which we can create a confusion matrix plot and check which ones were misidentified. Actually, these three here are all of them edible, and they're quite similar, actually. So a nice thing to do is with the classifier measurements result, we can also ask for the best classified examples, and as well for the worst ones. So it seems it had difficulty to classify correctly these ones, but you can see that they have some certain weird angles. Some is covered with some leaf, and this is even a rotten mushroom, it seems. But yeah, we can also test with a test set example, and in this particular case, was doing a pretty good job. As a good practice, I recommend you to also export the mushroom Wolfram net models in using the Wolfram language net format. So you, in case that you are restarting your session, you don't need to train again the model. All right, the next step is it's to export the trained net model using as ONNX file. So ONNX is it's the open neural network exchange file format that was created some time ago. I don't know if it was like a couple of years ago by some big parties in the industry of machine learning. And now there is a lot of companies supporting that file format. And now in 12.2, we have also the option to directly export Wolfram language neural network models into ONNX directly using export. So a good way to do is kind of a round trip check that the converted model was converted properly by just importing back again into the notebook. And as you will see, the models, the original model was a net chain, and the imported one is a net graph. They have the same layers, but ONNX doesn't have the encoder and the decoder. So that means that we need to dress up the neural network again using, for example, the net extract from the original model and then get the encoder, and as well as the decoder. We can use net replace part on the imported ONNX model, and then we will end up having a ready to train neural network. And not to train, but to test, sorry. So in this case, I'm using this toxic mushroom to test on both models, the original one and the ONNX one, and they seem to be doing the right thing. They have the same output probabilities. So it worked. As a last step, we need to convert this ONNX model into Core ML if we want to deploy it into an iOS operating system device, so like an iPad or an iPhone. And Apple released a Python package called CoreML tools for importing all types of net models. And you can see that they also have support for ONNX. So it's going to be one last step before deploying the net to the iPhone. For this, I was following the instructions from this workflow that you can check. I shared, by the way, I shared the whole presentation notebook on the Pathable link. And then if you're not familiar with the external evaluate function, you can just follow the steps here and be able to run Python code directly on your notebook. You will also need to install the CoreML tools from Apple Python package, as well as the ONNX one. Once you have that, it's good to note to know that the kind of CoreML models they have similar way of working as the Wolfram language models. Which with this I mean that they have a kind of encoder and decoder. So we will need to specify from the ONNX model during the conversion of the ONNX model to CoreML to specify some pre-processing arguments and also add the class labels for the mushrooms. So in particular, we have to pay attention to the input port and check certain properties here. In this case, we want to make sure that the mean image of each color channel is also pre-processed correctly in the CoreML model. And also, you should be aware that the pixel values range are from 0 to 1 in the Wolfram language, but in CoreML, the scale is from 0 to 255. So we will need to also, in the pre-processing arguments, we will need to specify the image scale. As well, the color bias, which are mainly the values from the mean image up here. And for kind of specifying the class labels, we only need to export as a text file the class labels separated by a new line. And these will be specified here. I'm not gonna enter into much detail on the Python code, but this is all what you need for specifying the path of the ONNX exported model. and then also save the model, the ML model, with the proper name and folder. And once this, if all this works well, you will get such an output of converting all the layers from ONNX to CoreML, and hopefully it will at the end say something like model compilation done, and then we can test it with CoreML tools that the model is behaving well. And here you will need to import as well the NumPy package, as well as the PIL one to import a test image. Here is a parcel mushroom. So, and then doing some image resizing and check for the top 3 probabilities. And these are the outputs, and we can check with our original Wolfram model, which the probabilities are pretty much the same, with except with an error of order 10 to the minus 2, which it's kind of fine since they're doing some different image preprocessing. So we have a kind of CoreML model working well. We only need to deploy it to the iPhone. For this last step, you will need to register as an Apple developer and install the Xcode beta. You will not need to know Swift programming languages here, so we will need only to download the classifying images with Vision and CoreML tutorial from Apple, and downloading this Xcode project will give you such window. I think I have Xcode open here. So instead of, and here you will see, instead of this mushroom Wolfram net, you will see a mobile net, neural net model, which you have to replace it for this one. And here you can see that we have already our mushroom species labels, 17, and also the layers distribution. And as in the preview section, we can test already directly on Xcode without needing to deploy it to the iPhone. So let's try with some toxic mushroom Amanita phalloides, and you can see that it's working already well. As a final step, you need to modify one of the Swift files. It's the image classification view controller file. Here you need to replace the mobile net for your own model. So here's the mushrooms Wolfram net. And once you add this class here, you are good to go and connect your iPhone, and then press the button for build and then run. And that should be it, I think. Here there is some test that I was doing in the forest, I think during the weekend. So I will just show you the screen of the iPhone. I was going into the woods and I found the mushroom. And actually I took it and I was eating it, so I'm still alive. It was not the second option, which would be like deadly. And these are some other mushrooms I've also found during the last days, and all of them were correctly classified. Yeah, I was double checking it with some mushroom expert. And if you have any question, I would like to answer it, and please check out the notebook, and think that's pretty much it. In the future, I would like to also do it one example with audio, but it probably will take more Swift code for in this process. But yeah. Is there any question? Should I check, refresh the a question from Danny about how well, so comparing different models. I think that the best one right now is Efficient Net, and which is going to be available in 12.2. So I would advise you to check Efficient Net in the future, which is the best performing one. You should be careful on not taking an efficient net model which is too heavy in memory, that they can be up to almost 1 gigabyte or so, or even more. So you should take some kind of light efficient net. I think that these are the best performing ones. So in the future, I should also do an example using efficient net. Yeah, I should warn you that this was just a toy example. So do not use this classifier for cooking without expert consultation. Actually, mushrooms can be quite deadly. Yeah, I think I was not completely putting my life in hands of Wolfram Technologies, so I really also consulted with my grandma, which has more experience on mushrooms than me. I think in the near future, I will kind of create a workflow for this presentation, and maybe even write a Wolfram blog post about it. And I hope to also have more examples that are not just image classification examples, but yeah, maybe the next one is going to be one for audio. I think I would say that, yeah, my grandma is really experienced on the edible mushrooms, but she doesn't know much about the real toxic ones. So I would also check a good guide, or yeah. And then I think the best one is also to upload the picture on iNaturalist, ask for expert consultation, experts there. And yeah, if you have some kind of doubts that the mushroom could be toxic, you should not eat it, because there are like so many species of mushrooms. Here I was using 17, but there are actually many more. Yeah. I mean, so this is toxic, but some people are eating Amanita muscaria in some cultures, and it's also psychoactive. If you boil it really well, it's not psychoactive or neither toxic, but it's always a risk. Right. So I was thinking to start with some audio identification of bird songs. I did my Wolfram Summer school project a long time ago on that, but I should update it with the new audio functions, and it's a bit tricky because the audio encoder for the audio identifier, it's a bit different than the image encoder, but I think it's gonna be at some point an example on that. Yeah. So yes, I think at some point I would like also to create a study group on such applications and topics. Yeah, for Android, it's up to the ONNX point. It's the same workflow, and from there you have different options. As there's ONNX runtime, and I haven't worked out any example. There might be some examples from others at some point soon. Yeah, for importing species observations, there are also some other functions I did in the past, like iNaturalist import, GVIF search, GVIF import, and kilobyte data. I think these three here can be also useful for you to build up some classifiers on animals or plants. All right. I think there are no new questions, right? So thank you very much for your attention, and hope if there are more questions, you can always ask maybe in the machine learning group in community, and I will try to have a kind of check them.